Hello everyone, my name is Silvio. I am presenter of this paper named A Counselors-Based Intrusion Detection Architecture. The other authors are Carlos Ranieri and Raul from UFSM, Célio and Diego from UFF, and Daniel Massef from University of Pittsburgh. Intrusion detection system may be anomaly-based, specification-based, or signature-based. In particular, the signature-based method relies usually on data classification algorithms. Data classification algorithms usually have two main phases. The first one is the training phase, where normal class and attack classes are inputted to the classifier algorithms in order to build a model, and then in the next step, at the intrusion detection phase, the unknown samples will be classified by the trained classifiers, and a final decision will be outputted. There are many classifier algorithms, and there are some systems that use multiple classifier algorithms in order to combine its output to improve the final decision. So, for example, if we have classifier 1 and classifier 2, even with the same training samples, these classifiers will be presenting different outputs or conflicting outputs. So there are many works that try to solve this problem, to combine these multiple classifier outputs to improve the final decision. The first method that I will present for you is majority voting. For example, consider that we have three classifier algorithms, C1, C2, and C3. Suppose that C2 and C3 classified an unknown sample as attack, and classifier number 1 classified it as normal. We will rely on the majority voting classifier. So the classifier 2 and C will be take its results for the final decision, that is an attack, because it's the majority output. Similar, there are the methods that uses weighted voting approach. This approach relies in two basic phases. The first one is the evaluation phase, where each classifier is evaluated classifying no samples, and its results will be measured in order to decide which is the weight of each decision. So, for example, if at evaluation phase C2 and C3 present attack with an accuracy of 60 and 30%, it is a not very high accuracy. However, the C1 present an output, a different output, that is the unknown sample is normal, and this classifier was 99% of accuracy at evaluation phase. So by weighted voting, we will take result from the first one classifier as the final result, final decision. The third one approach for using multiple classifiers is the best local. That relies on clustering algorithms in order to split all the evaluation samples, and for each cluster of samples, all the classifiers are evaluated. So we will detect, we will select the best classifier for each cluster for as the classifier to taking the final decision. Then, in detection phase, when a new sample comes to IDS, the IDS will first cluster its new sample into one of the generated clusters. So, for example, if this sample is clustered into cluster number 1, the classifier number 1 will be selected to take the final decision, because at evaluation phase, the cluster number 1 was the classifier number 1 as its best classifier. So, our proposal is to improve all these methods by using multiple and heterogeneous data sources, and we will be able to use multiple classifier algorithms, and we will propose a counselors network for exchanging knowledge between the multiple classifiers or the multiple detectors that have multiple classifiers. Each classifier can be trained with different kind of data sources, and these different nodes of detection can share information for solving conflicting cases. And after a conflicting case was solved, all the IDS nodes are able to do self-learning. So basically, in our proposed architecture, suppose that we have classes of normal and we have samples of normal and attack classes. We will use these null samples to evaluation phase, and by using a clustering algorithms such as k-means, we will perform the clustering and split this evaluation data in multiple clusters. For each cluster, we will select the best classifier based on its accuracy on detecting null samples, labeled samples. Then, at detection phase, suppose that we are looking for network statistics, for example, and this information, each sample of this information will be clustered, and after the clustering decide what is the cluster that this null sample belong, we will use the best classifier for each sample, for each cluster, for taking the final decision. However, different from the best local approach, we select more than one classifier, because both classifier 1 and classifier 2 presented a good accuracy. So, if both classifiers present the same output, we will rely on this output to take the final decision, even normal or even attack. However, if multiple, 2 or more good classifiers present a different or a conflicting decision, we will have a conflict case. So in this case, the previous work does not can solve this case of conflict. So we are proposing counselors network for enabling the exchange of advices between multiple detectors in order to solve this kind of conflicting situation. Our counselors network considers that we have multiple kinds of detector nodes, and inside of each detector node we can have multiple classifiers, and each detector node can analyze a different kind of data source. So basically, a detector conflicting node will ask for advices for the counselors network, and this counselors network will rely on its historical analysis for taking the correct decision for response the request, the advice request. And finally, detector 1 can use this advice for first take the reliable final decision and output the expected classes, the output classes as a result of the counselor network. And finally, 2, detector 1 can update its model by storing this advice as a new signature for training, retraining, rebuilding the model of each classifier inside the detector number 1. That is the conflicting node. So basically, the data suppose that in the previous case that is shown in top of this image, we have a conflict case, and we will ask an advice for a different data source. Suppose that the first one IDS is a network-based IDS, and the second one is application-based IDS that analyzes application logs from data source. So detection node number 1, or detection node network-based IDS, will ask an advice for the second one, and this detector node, based on this analysis, will respond this request sending an attack flag. So after receiving this counsel, the network IDS will output that is an attack. In addition, this information will be stored, and the classifier number 1 that is wrong will be punished, and the classifier N that is the correct classifier will be awarded. In the next evaluation and the next classifier selection, it's expected that the awarded classifier have a preference in the output decision and in classifier selection. So in order to evaluate our idea, we use 2 data sources. The first one is NSL KDD, and the second one is SIG IDS dataset. As extractors, we used SIG flow meter that extracts network traffic analysis for the second one dataset. And for the first one dataset, we don't use extractors because this dataset is already extracted. We used Firebase real-time database because it's provide the information at real time. As detectors, or our detectors was implemented by using Java language and by using Weka library to allow us to implement the algorithms, both classifier algorithms and clustering algorithms, to perform classifier selection. So the first evaluation that we performed is to prove that our idea works. In this first experiment, we have 3 detector nodes, and we will take a specific case of conflict between the classifiers of detector 1 to try to solve by requesting a device to the counselor's network. So consider that a different kind of data source was inputted to detector 1 and detector 2. So detector 1 in a specific case was clustered the unknown sample into cluster number 3, and in this cluster the best classifier are both IBK and NB3, both with 95% of accuracy. However, this unknown sample was classified in a different class for each of classifier. So detector node number 1 doesn't have the capacity to define if it's a normal or a attack sample. In this case, detector number 1 will ask an advice for detector number 2, and detector number 2 that clustered and chose a J48 classifier as its best classifier, and this classifier was outputted a tag for this specific sample, enables the detector 2 to respond to the requested device with an attack flag. And in addition, this response will have a confidence of 100 because the J48 was on 100 in its evaluation step. This is the accuracy of J48 classified algorithm in the evaluation step. So the conflict was solved and the correct classifier was awarded, and the wrong classifier was punished. In order to verify if this idea works for many samples in a larger dataset, we used the CKIDS, where in each of the 5 clusters generated by k-means, we have about 70,000 samples per cluster. And we have 2 different detector nodes, each of the same datasets, however, each with a different kind of acknowledgement. We used a set of attacks to train the first one, and another different set of attacks to train the detector number 2. In this case, as a result, many conflict cases were solved, thus allowing the best accuracy compared to the other techniques like best local weighted average and the majority voting. And regarding the second one, evaluation experiment, we have this result. In this graphic, we can see that our proposed solution was achieved the best accuracy for detector number 1. It was also achieved the best accuracy to detector number 2. In addition, the best local approach here was achieved the same accuracy for detector number 2. We noticed that in this case, detector 2 was presented less conflicts than detector 1. So in detector 1 we can solve more conflicts and we can improve a lot the accuracy. Note also that the naive base was the poorest accuracy. Regarding the detection rate, our approach also was presented the best detection rate for detector number 1 and the best detection rate for detector number 2. That also was the same that the best local approach, for the same reasons that I said previously. Notice that in the single classifier there are an algorithm with a high detection rate, that is naive base. However, remember that it is not a visible solution because even with its high detection rate, this classifier was presented many false positives, so its accuracy was very poor, as I said in the previous slide. Finally, to conclude, we presented a novel IDS architecture. It consumes multiple and heterogeneous data sources. It performs dynamic choice between multiple classified algorithms, and it enables advice exchanging between multiple detectors by the proposed counselors network. As a result, we show in 2 use cases that the idea is constant and that many conflicts were solved without the human intervention. As future work, we plan to extend our approach by employing big data technologies to deal with scenarios of a huge amount of traffic. In addition, we expected to explore other classified algorithms and clustered algorithms, as well its detector parameters. It's all, thank you. Now we have questions.